What's up, probability rock stars? It's time for video 27, permutations and combinations. All right, we've got two essential questions here. The first being, what's the difference between a permutation and a combination? And then can you find the total number of outcomes? The reason why the first question is so important is because if we can't tell the difference between the two, we cannot choose the right formula. And the formulas are different. All right, so here's our answer. What's the difference between permutation and combination? Permutation is like asking something like, out of 10 people, how many different orders are there to rank a first, second, and a third place? Or out of 20 people, how many ways can I pick a president, vice president, secretary, and treasurer? Notice for the permutation that order does matter. So for example, if I chose, I've got 10 people and I chose Che and Parker, and I was going to be doing president and vice president, well, one situation where you have president and one is when you have vice president. So that would count as one, but actually if I swap these and I call Che VP and Parker president, that would be a second situation. So in general, there's more permutations because order does matter. There's a few hot words here you should look for. Anything that has to do with giving places or giving positions or order matters, that's when you know it's a permutation. Now combination, order does not matter. So an example of that might be any type of race where you're just getting t-shirts for the top 10, doesn't matter what order they're in. Maybe you're finding student senators, you're not, here we would have 10 people and we chose Parker and Che, and he's a senator and Che's a senator, but that's it. We couldn't swap them because it would be the same thing. All right, now what's the best way to remember this? I always remember the fact that if you get a combo at a fast food place, you're gonna get fries, you're gonna get a drink, and some sort of meal, let's say in this case a hot dog. Now, is that different at all from getting a hot dog and then fries and a drink? No, that combo is the same thing in any order. In other words, order does not matter for combos because it's the same thing. So that's how I remember that combinations are where the order does not matter. Okay, now you choose here. My fruit salad contains grapes, pineapples, strawberries, and blueberries. Doesn't matter what order I place the ingredients in my bowl. Which one is it? This one's a combination because the order that you put the fruit salad in the bowl does not matter. For example, grapes, pineapple, strawberries, blueberries is the same thing as blueberries, strawberries, pineapples, grapes. That's kind of the same situation with the combination from the fast food restaurant that I was talking about. How about this one though? Is it a permutation or a combination if I'm talking about my locker combination of 23, 5, 17? Does it matter what order I turn the numbers in? Which one is this one? If you said permutation, you're correct because the order does matter. So 23, 5, 17 is different than 23, 17, 5. Here are the two formulas. So here, the P stands for permutations, and if I had something like this, 10, pick 3, I read this as 10, pick 3, meaning I might have 10 students and I want to pick 3 positions, maybe a president, a vice president, and a secretary. And so that's going to give me a fairly big number. It's going to come up with all the possibilities of assigning those 10 people to be a president, vice president, and secretary. Now, if I did 10, choose 3, I might be saying, hey, out of 10 people, choose 3 to be in the cabinet or to be senators, right? That way the order doesn't matter. And if I've got Brian, Che, and Nadia, that's the same thing as Che, Nadia, and Brian. Versus up here for permutations, we're assigning positions, and so that order does matter. Just a reminder, I've got a video on how to do factorials, but just as a quick reminder, you go to math, then scroll over to probability, and then scroll down to factorial. This is just a quick reminder that N stands for the set size, the total number of items in the sample. Usually we're talking about people or sometimes things. And R is that subset size, the number of items we want to select from that. And sometimes you'll see this notation, but on your calculator, you'll actually see it like you did on the other slide. The question is, why does this work? And I'm guessing you probably don't care. If you do care, though, I've got this slide for you right here to try to explain to you why this works. You can pause this video and read it if you'd like. I'm not going to test you on it, but I just thought I'd throw this at you if you wanted to know why the formula worked. All right, let's actually just dive into a problem right now. This is an example of a combination. I want you to pick a team of 3 people from a group of 10. Well, if I'm looking for a team of 3, that's definitely a combination because Braden, Brenda, and Abe is the same thing as Abe, Brenda, and Braden, right? Because I'm just trying to pick a team. So what I'm trying to find here is 10, and I'm trying to choose 3. So this is going to be equal to, and remember, look at this formula down here, n factorial. N is the number of people, and so that's going to be 10 factorial divided by n minus r. Remember, r is the number of things we're trying to choose. This is n, this is r. So n minus r is 10 minus 3 is 7, and then we put a factorial there. And then we've got r factorial, which is going to be 3 factorial. Now, I would recommend doing this on your calculator. If you want, you could do 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by, those on the bottom as well, but I wouldn't. Just be careful if you're doing this in your calculator, make sure you put parentheses around 7 factorial and 3 factorial, or else your order of operations will be off. Please do this now and check that you've got 120 outcomes. All right, hopefully that matched. There's another way to do this problem, and again, I've got this video for you to look at. How to do 10 choose 3 in your calculator. Well, you have to first press the 10 button, and then you have to press the math button. And I do have a video on this, so if you're saying, hey, I need to see a visual of this, I do have that video for you. So then once you're at math, you're going to scroll all the way over to probability. And you're going to pick, and because this is the C one, the combination, you're going to choose number 3 here. It's going to look like this, 3 and then N choose R. Just make sure you put the 10 in first. Okay, so this is going to look like 10, and then it's going to have this NCR thing, and then you're going to put 3. And after doing that, you should also get 120. And that's the way we want to do it from now on. But I do think it's important to see the formula and also know what factorials are. All right, let's try another one. Whoa. All right, let's do a permutation example. Let's pick a president, vice president, secretary from a group of 10 people. So this is going to be 10, pick 3, and the order does matter here. So you would assume that we're going to get more possibilities because when we had Brenda, Braden, and Abe, that was just one selection, but we could have put those in a different order for this one. All right. So this formula, we look down here, and n factorial, remember this is n and this is r, is going to give me 10 factorial. And then this denominator is just going to be, so we do 10 minus 3 here, and we get a denominator of 7 factorial. Again, put this one in your calculator, and we get 720. And we've got 720 ways to organize that. Now let's go ahead and just review how you do this on your calculator. You first put your 10 down, then you press math, then you scroll over to probability, then you pick the NPR one, and so you'll have NPR. And then that would be a 3, and it will give you 720 ways as well. If you want to use your formula, you're absolutely welcome to do that as well. All right, now maybe pause the video and try this one on your own. Okay, what'd you get? You should have done 7, pick 3, because you are awarding a first place, second place, and third place. The order does matter. You should have 210 ways to do this. Did you use the formula or did you use your calculator? Doesn't matter to me. All right, maybe pause the video and try this one as well on your own. All right, this one's a little tricky because I kind of tricked you here. It's not actually a permutation or combination. It's actually a counting problem, right? We're trying to figure out how many possible designs are on top. This is actually one of those slots. We've got 3 slots. So we've got white chocolate or yellow cake. So we've got 3 options for that. And then we've got chocolate or vanilla ice cream. We've got 2 options for that. And then we've got 20 possible designs on top. So 3 times 2 is 6 times 20 is, of course, 120 possibilities here. And the way you can kind of think about why this was counting principle and not permutations or combinations is we're trying to come up with a total number of possible designs, and each slot has a different situation there. Oh, that was just me explaining. All right, number 4 here. How many different ways can you arrange 3 sweaters in a display window from 8 different sweaters? Well, does the order matter here? Is a green shirt, then a gray shirt, then a light teal shirt the same thing as changing that order? Yeah, it is important that you change the order, and the order does matter here. So this is going to be permutations. So this is going to be 8 sweaters, and you're picking 3, and that's going to be 336. And that's going to be arrangements. Okay. I've got a quick class challenge for you. How many different poker hands are there? Okay, remember you get 5 cards in poker. Does the order matter in your hand? No, not really, right? Because you can always rearrange them and it's the same hand. So to figure out the poker hands, you would just do combinations, and I'd like to rewrite this. I know you should be aware of this, but this is 52 cards and you're choosing 5. You can go ahead and do that out with the formula or just do it in your calculator. You've got about 2.6 million possibilities for poker hands. But how about blackjack hands? What would that look like? Well, that would be 52 cards and we're choosing now 2. We do that math out and there's only 1,326 possibilities that you could have for initial blackjack hands. And it's really even less than that too if you think about it, because like a jack of diamonds and a 5 of hearts is really the same thing as a king of hearts and a 5 of diamonds. And so, you know, I'm just asking about cards looking different. So that would be kind of a good enough answer for me. I'm not going to ask you these questions. I just thought it was super interesting to look at it. All right, that's it, folks, for our combinations and permutations lesson. Thanks so much for watching.